11, finding the area of regions bounded by a curve or line and a curve. All right, so let's go through this concept by looking at an example. So I think that would really help us to understand and work out questions involving area between regions. All right, so if you look at this example, the area that we wanted is actually between the curve 2 root x and x itself. If you can't see it, it is basically around here. Okay, so what is the technique to actually find that area bounded by the region? So we look at number 1, which is the upper curve or upper line. Okay, so the one that is higher in this case is 2 root x. So this will be my upper curve. All right, and then the line y equals x, that will be my lower curve. I'll call it just gx, or curve or line. Okay, so if you were to look at finding the area between 0 to 4 of the upper curve, I'll put it in red. This would be the area. Okay. All right. So if we look at the area bounded by the lower curve by y equals x, 0 to 4, I'll put it maybe in pink. Yeah, this will be the area here. Notice that when these two areas kind of like intersect each other, the only area that is not eliminated, if you're going to subtract the big area, which is bounded by the upper curve with the lower curve, whatever's left over is actually this green part here. All right, so what we want to do is basically we want to look at the area of the upper curve. Area of upper curve, I just call it UC, all right? We're going to subtract it with the area of the lower curve, LC. And when we do that, we get the area that is bounded, all right, or shaded between the two functions itself. All right, now in general, this is the formula. We say A is equals to integral from A to B of fx dx, which is the upper curve, minus the same region A to B of gx, which is the lower curve, dx. Okay, so this is how it works. All right, so let's look at this example. Let's solve this. So we have the curve and the line y equals x, and the point of intersection is 4, 4. That's very important, because with that point, we can actually then find what is the region we want to actually find the area from. So it's between 0 to 4. Okay. All right. So let's solve this. So to find the area of the bounded region, basically we're going to integrate from 0 to 4 of the upper curve. In this case is 2 root x dx. We're going to minus it off from the region of the lower curve, which is from 0 to 4 of x dx. Okay, so let's work that out. This should get me 2x to the power 3 over 2 over 3 over 2 from 0 to 4, minus this would be x squared over 2 from 0 to 4. Okay, so let's substitute all our values in. We sub 4 in. This should be 4 over 3 times 4 to the power 3 over 2. All right, we're going to sub 0 in. Actually, everything becomes 0, so we can eliminate that. All right, minus, we sub 4 in. This would be 16 over 2, and we sub 0 in, it will be just 0, so gone. All right, so let's work that out. Can press it in the calculator. You should get 2, 2 and 2/3 units square. All right, so this area is the area in between here. All right, the area bounded. Example 24. So we have a line intersecting a a curve. And first, part A, you just want us to find coordinate A, B, and C. All right, so A, B are basically the roots of the quadratic, so we can just solve that quite quickly by equating y to 0. All right, and to find coordinate C, we just want to equate the quadratic function with the linear function and find the intersection. All right, so I've done it here. So part A, you can see that I have factorized the quadratic function, equate y to 0, and I was able to get A and B point quite quickly. 2n minus 2. And for C, I just equate the quadratic function to the linear line, and I substitute them together and solve it. So I have two answers, x equals to 2 and x equals to minus 1, but I will reject actually x equals to 2 because I know that is already my B point. All right, so if x is minus 1, then y would be minus 3. Okay, so next one, we want to actually solve for the area bounded by the curve and the line. So basically what's happening is that we are integrating from C point. In this case, C is minus 1, right? And B is 2. So we're integrating minus 1 to 2 of my greater function. In this case, my upper curve, which is x squared minus 4. Okay. And I'm going to subtract that with my lower curve, in this case, x minus 2. Okay, and basically everything with respect to dx. All right, so why I'm doing that, why is my x squared minus 4 the upper curve, although it seems to be lower, is that you kind of imagine it inverted upwards. So the x squared minus 4 would be like the higher curve, right? And the area bounded will be bigger compared to the area bounded by the line. So that would be the reason why I consider that as my upper curve. And yeah, x minus 2 would be a lower curve because the area occupied will be smaller. So a bigger area minus a smaller area should get us the area in between in this case. All right, so let's work that out. You will notice that when you work out the answer, it will be negative. But don't worry, we can always mod it later, yeah? So let's expand out a bit. So this would basically be x cubed over 3. This would be minus x squared over 2. And then this would be minus 2x. All right, and we are integrating it from minus 1 to 2. All right, so I basically just expand it and just work it out quite quickly in my mind. So I think that's how we get here. Now you substitute 2 in, this should be 8 over 3 minus 2 minus 4. And we're going to minus that with negative 1 in, so it will be minus 1 over 3. This will be minus half plus 2. All right, so you press it in the calculator, you should get minus 4.5. All right. Now, like I said, I already predicted that the area is going to be negative because it's below the x-axis, right? So what we're going to do, we're just going to put mod sign all across. Okay. And yeah, that should be it. So you get the area of 4.5 units square. All right, so this is how you solve part B. Hope it's clear. All right, if there's no question, you can proceed to do the extra examples in Firefly. Otherwise, I hope this video is clear. All right, I'll see you next video.